Hello everyone, my name is James Ryan, and today, a couple of days ago, I finished high school. I finished my exams, and now that means I have a lot of free time. Well, there's obviously stuff I still need to do, but I now have a lot of free time and I can finally start making these YouTube videos, I can't wait. There's a lot of stuff I want to get through before the end of the holidays, but I thought I'd just start with this very first unstructured video, and I think this will be, I want to make a vlogging series. This will be vlog number 1. It'll be a very unstructured series. It could revolve around anything. It'll either just be me talking to you about stuff, or we might play a game. I might show you some music, might show you a project, might show you some interesting programming I've been doing. Might be all of those things, might be none of them, might be a mix, but it's just supposed to be whatever I want. Time will tell if I just keep with that unstructured format. And then sometimes maybe there'll be specific episodes dedicated to a particular thing, or if I eventually specialize in different series where I do different things in different series. Who knows? But that's not the point. What I've learned from my previous experiences is best to just start simple, nice and easy, and go with the flow, see how I go from there. Now, the observant among you may have noticed that I'm drinking Coke, and the even more observant may remember that I said I was going to stop drinking that. I'm talking, of course, about people in real life. I probably haven't mentioned this on the intranets, but no one really is watching this apart from probably Dilshan and a few other people from my school at the moment. So, look, I'll stop drinking eventually. Maybe by the end of these holidays. Maybe not. We'll see. So, I think the first thing I should do is I'll make my face small. Probably making all the wrong hand movements. I'll make my face smaller in the corner of the screen. Maybe we'll go through some of my programming that I've done. Processing. I can't really show you the Arduino because it's kind of like 11 o'clock. So I haven't really done anything with it for a while, so it'll be a bit rusty. But apart from that, yeah, I think we'll do that. We'll go through some music, and then I'll play some Team Fortress 2 or something, and that'll be fun. So yeah, let me just resize my face. Turns out I never actually made my face big to begin with, so it was 20% the whole time, so I don't have to resize it, which is good, I guess, but also means that you just get to see a tiny face for the first part of the video, which isn't that good, but hey, this isn't professional or anything. Holy crap. I swallowed that wrong. Good. And that was my first trick, capturing a human survival gag reflex on camera. Yay, biology. No, that was unintentional, obviously. Where was I? What was I gonna do? I'm going to show you some programming. Sorry, I have some OCD where I need to crack my neck. It really hurts it actually. So just a second. Okay. So going on to the processing environment, processing to an open project initiated by... Oh, went really fast that time. Probably because it wasn't the first time I loaded it up. So let's take a look. Well, this one's really good. A-star search. Check this out. I coded a generic A-star pathfinding program. And currently what I've done is I extended the classes towards nodes. So I've got this, currently got it pathfinding the quickest path to the red node, and I can place walls on this program. But the really cool thing that I guess you can't really show because of it's a kind of abstract concept, and it's actually built with abstract class, is that this isn't just applicable to pathfinding straight up, like actual paths. You can, the actual algorithm is coded generically, because I can show here that the A star search function only deals with these things called nodes, and these grid things here are actually things called grid nodes, which I've made as a specific extension of node. So it can actually deal with anything that extends the node class correctly. So I'm thinking of using it for say making nodes, extending nodes into functions. So maybe somehow A star pathfinding can find the minimum value of a function, like a global minimum thing, or and the other thing I was thinking of is multi-agent pathfinding. I can extend and abstract the problem of finding a shortest path to a multi-agent path, and then I can further abstract that to not just deal with like different discrete steps, but actually deal with time in a sort of continuous manner by keeping track of what time it is, and it'll be fun. May do that these holidays, may not. Let's be honest, probably not. But who knows? Get to it eventually. So yeah, this is fun. I can create a path, and it will not to ever take a longer path than necessary. Always finds the shortest path that it that it can take. And I can force it to take a sort of convoluted path. Like that. And of course, if I completely block it off, it tells me it doesn't display a path and tells me it failed to find a solution. So yeah, that's good. Other stuff, you'll get to see my Schrodinger program. I'll probably show these off in more detail at a later date. Maybe even go through the mathematics behind it or something in some separate. I don't know if that'll be a vlog or if it'll be some other type of video. But yeah, these things are quite really cool. Let's take a look at this one actually in particular. If I go like say 300, and then I change the initial function. This is my simulation of the Schrodinger equation. It's really cool. How do I do this? There we go. I'll just comment this line of code out and we'll see how it goes. So there it is, finding the lowest energy. But with just a few small changes, I can do the famous particle in a box ripple effect, where it forms these standing wave patterns, and it looks like this, and it's really cool. It goes faster if you make the box smaller, so but that's not part of the electron or anything. That's just the simulation speed increases when there's less to simulate. But it looks really cool, and I can't wait to show you this in more detail. Exactly what's going on, how it works. It'll take a long time, but I'm up to the challenge when I have the time. So yeah, and then it coalesces into one thing, and then it splits apart again and sort of bounces back, I guess, in quotation marks. Then it becomes 3, and then it becomes 2, and then it becomes 1. I think it becomes 3 and then 1 again or something. 3, and then 1. So, interesting. I recently posted like a 2-dimensional Schrodinger video, showing me finding the lowest energy wave function for a 2-dimensional dihydrogen cation. I've currently repurposed the program so that it will step through the energy levels of hang on, I gotta check if this is doing it right. Yep. So I've currently got it just a second. Calculating the energy levels for different amounts of internuclear separation of that particular atom, so it can find. So those videos I showed you were at the separation. It was kind of an interesting video. Kind of an odd video. I didn't really talk much because I wasn't really prepared. I was just making a really quick video, and I kind of just put on a song over it that I was interested in at the time, and yeah, not the most professional video, but gotta find the right place in here. Come on. Ah, yes, let's change this to 10 instead of 25. Don't need to. Better for a fast simulation than an accurate one. So what I've got it doing is I've got the simulation here, but I calculate the energy from the simulation, and I'm graphing it over as I change the internuclear distance. I started off at 0.5 and I separate it, increasing it by 1 at a time. I've also got things offset, and they have to be offset in a particular manner in order for the graph to come out smoothly. I've noticed that due to the way the simulation calculates the energies is slightly higher or lower, depending on and the way the wave function acts is slightly higher or lower depending on if I've got the protons at a point or how close I've got to an integer point. It's kind of hard to explain in a short time, but basically you can see that I'm varying the separation, and it's generating a nice graph, and it's already showing the minimum point there, so that little amount of so it's already too far apart now. Going back there would be the perfect amount of separation. Of course, I finally figured out why I was having so many problems. I was having some problems with energy calculations. Like, I would get the right energy if I set these particular numbers. I'd get the right energy for I'd get the right energy for the hydrogen, and I would get the right energy when I went for hydrogen on its own, but then get the wrong energies for a dihydrogen. And then if I set another set of numbers, it would get the right energy for the low point of the dihydrogen, but not apart, and all that, and vice versa. But I think I finally figured out that obviously I'm not going to get the right energy levels because this is only a 2-dimensional simulation, and real atoms are 3-dimensional, so of course I'm going to get different energies. This isn't a real thing. Well, that's a philosophical point. I think it's sort of real. It's sort of a real atom. Sort of. But in any case, it's a 2-dimensional one, so it's definitely not going to come up with the same amount of energy as a 3-dimensional one for sure. So, but it does produce a very similar graph, which I can show you if I go to the Wikipedia page and overlay a dihydrogen cation. You can see here that if I open this little thing here and compare it to my graph that I've created, we're looking of course at the lowest line. All the rest of them just go straight down except for the very lowest energy state, which has a minimum around 2 Bohr radii. So mine has a minimum such that the graph looks kind of similar. Of course mine's a bit more scaled. So, and obviously mine is two-dimensional and this is a three-dimensional one. But apart from that, they have the same basic shape. A big downward line starts to curve, then goes upwards, and eventually becomes a straight line. Now, my simulation has a bit of a peculiarity. When these atoms start going near the walls of the simulation, of course, real life doesn't have walls. The universe apparently has no edge, but in my simulation, the simulation does have an edge. So, and when the nucleus starts to go near the edge, the energy level starts to drop a little bit, and then starts to rapidly rise as the electron kind of decouples from the proton, because the proton can pass through the edge, but the electron can't, and it's odd. As you can see, the energy level's already starting to drop, and that's obviously doesn't happen in this thing. But yeah, I found a way to output. What I did was I exported this application and I opened it up in the command line and I piped the output into a text file. Then I went into Google Sheets and I copied the output, and this was one of the wavy outputs, but I was able to stabilize it and actually get out extra information, sort of, by replacing each value with the average of the value of the two values around it, not the average of that of the three values, but only the two. It works out pretty good, and I'll show you what that looks like. It does give you a bit high values though, so that's why I've switched to only using the leftmost values, because I've got both sets of values here. So if I just plot this, if I just put this on its own sheet, you can see I've got roughly the same curve in it, I've deleted the top half, so it looks actually quite a bit like the Wikipedia one. But of course it does go down. These orange values are the interpolated ones, and the blue values are just taking the bottommost ones. I don't understand why they haven't joined the lines though. How odd. Anyway, no time for that at the moment. Here we are. Maybe there is time. Whoa, no, bad. What have I done? Oh crap, there we go. Data label, size, shape. I don't know. Anyway, so that's the programming I've done in a nutshell. There's a lot more. There's this one, which uses an extension of Newton's method involving dividing vectors, which I kind of figured out on my own. Then I realized it is used elsewhere in something called algebraic geometry. But yeah, I figured out basically how to solve these two-dimensional equations for particular values. And so, for example, here is a simulation of not a simulation, but here is it finding the Hamiltonian paths of a pendulum. And if you look at the Wikipedia page for the mathematics of a pendulum and the Hamiltonian path, you'll see that these should look pretty similar. And I've also got it plotting the energy levels by the rainbow. I've got a simulation of light waves and the interference pattern that light produces. So if I run this long enough, you should start seeing light waves coming out and then interfering with each other, and that's pretty cool. And this is using the transfer matrix, what's it called? TLM, transfer layer matrix or something. It's a transfer matrix method of some kind. So it doesn't actually involve any of Maxwell's equations, but it is equivalent to Maxwell's equations, using some type of a transmission line analogy. That's what it's called. It's called transmission line matrix method. So it's very interesting. And yes, this is technically a sort of cellular automata, but it's a bit more complicated than your regular one, because instead of cells holding their own values and then updating based on other cells' values, cells kind of function as nodes which input and output values, and so each has a set of outgoing values in different directions, and then it takes those which become the incoming values for the adjacent cells, and then each cell has to process those incoming values and turn them into the outgoing values by adding them together in a particular way. But it works, and as you can see by the end of this, they've done that. And if I turn the waves on really long for a little bit longer, you'll be able to see the interference pattern after it's gone on for a long time. So I'll show you that, and then now that it's been 20 minutes, maybe we should play some bit of Team Fortress 2 for the next 30 minutes, and then I'll have to get to bed. So yeah. Okay, coolio. I'm liking this uneditedness. The next video of this will probably be one that I recorded much earlier in the year, because what I did was I originally wanted to start this series a lot earlier in the year, and I think I recorded about 2 episodes, and then I kind of said, no, I'm not going to be able to do this properly while I'm supposed to be focusing on school, so I didn't really do anything with it. But now I can. So but the problem is that if I just show that without any context, it won't really make sense, and I make a lot of promises in that video that don't end up happening, and so I'll have to start it off with a bit of a preamble, basically explaining that yes, this is a video from the past, and no, some of the things I say in it aren't happening, at least, don't really make sense, and I won't be doing this or that or stuff, but some of what I say is true in terms of what I have planned, but it's kind of complicated. But anyway, here's the interference pattern, and then of course I can turn it off the wave. It takes a bit of time to shut off, but yeah, there you go. It's pretty cool, isn't it? You can even see the previous wave that I created traveling in the backwards direction. I haven't quite figured out how to properly absorb the wave at the boundary, so it kind of half... I haven't figured out how to properly absorb the wave at the boundary, so it kind of half reflects back. So yeah, there you go. Pretty cool, hey? So that's an interference pattern. I haven't really managed to get the interference pattern with the Schrödinger equation per se. Haven't really tried, I guess. I mean, the first thing I really should do is standardize it, because, man, that is a cobbled together program. It's got a lot of commented out code from previous experiments, things I've tried with it, like that time I tried to do Bohmian mechanics, and that worked really well, but I don't need it anymore, but I still want to keep the code, so it's kind of stayed in there, and I need a way to archive it without completely getting rid of it. This one is an interesting one. So this is based on some guy's crazy idea that physics was actually a bunch of particles traveling around each other in circles. So I tried to create that. I tried to create a physical simulation in which the particles had momentum, and they kept going the same direction they were going, but they also had to travel around each other in circles, so they were kind of constrained in their momentum. They always had this acceleration such that they perfectly traveled around each other in circles, And the way I did that was not by actually I've probably done it wrong, actually, now that I think about it, because I think I've made them all travel at the same speed, sort of by accident, but at the very least, like their moment. Oh no, because they're also all supposed to travel at the speed of light. So yeah, so they all travel at the same speed, and they all can only travel around each other in circles. And the problem is that they all started eventually going apart from each other. So I decided also to scale them so that they so that the furthest two could only be a certain distance from each other. And so this is the result. When I say constrained, so they could only travel in circles around each other, what I mean is, like, I programmed them to travel in circles. Like, I did not calculate forces and apply that. Like, it's just inbuilt, sort of. I'm not sure exactly how I did. I don't remember. It was a long time ago. But it's crazy, and it doesn't work. I think I kind of figured out that what the guy was thinking about didn't make sense when he started saying that neutrinos can't exist because they don't interact with the real world enough. And he was saying, yeah, and he was giving a rebuttal to the fact that we've detected neutrinos by saying, look, we hardly detect any of these things. Like, how do we know it's not just random blips in things, and that it's even real? And obviously, I can easily point to three things about when we definitely detected neutrinos. One was when there was some type of stellar explosion along from far away, and all of a sudden the relatively rare neutrinos that we only detect about 3 a year, all of a sudden 10 were detected. 16 were detected in the range of about 3 seconds or something, all over the world. So that's telltale. And also, there were experiments to detect them where we had a measurable increase in the amount of detected neutrinos from when a nuclear reactor was turned off versus turned on. This was an above-ground experiment, so instead of the very rare, neutrinos, that only the most energetic ones went there. This one was probably one of those ones where we got a lot of things, but it was measurable. And of course, they're actually planning them to use this mechanism in the future to sort of covertly. It's kind of interesting. Like the US government wants to covertly measure Iranian nuclear reactors from far away using neutrinos to make sure that they're doing what they say they're doing, or something like that. I'm not sure. Anyway, so as you can see, this physics thing is interesting, makes interesting patterns and shit, but it doesn't. I don't think it works, because things tend to really just go around each other in circles. If I increase to about 15, I think 15 things. And it's kind of interesting at first, but then it very quickly turns into basically particles exchanging their positions around the edges of a circle. Sometimes they skip across, but it's interesting. It's very interesting physics of some kind, but it's not physics, and it's not how the real world works. I would like to show this, see if this would be welcomed at an art exhibit or something, because it's definitely right up an artist's alley. Oh, speaking of which, there are things in the Schrodinger equation I haven't managed to show you properly that are really beautiful if you set it up right, and it's good. This seems to be freezing. Maybe I should... Oh gosh. I didn't even press the quit button, man. What are you after? Do you want me to quit? Whoa. Okay. I'm gonna quit that. We're gonna play some Team Fortress 2. Okay? Whoa. Yeah. Could not handle the weird laws of physics. So I'll be back with Team Fortress 2. So, welcome to Team Fortress 2. I haven't played this in quite a while, but hopefully it's enjoyable to watch. And hopefully I get into a good server where there's not someone talking or something. Manpower, I haven't played that yet, but I think I'll stick to... Wow, recommended for expert players. Wow. I think I'll stick to, say, payload or something. For the King of the Hill is pretty good, actually. Let's play as Scout, because he's one of my favourite classes to play. I really like being fast. There's a new game going to come out called Overwatch, and if I'm able to other modes, but I really like the class-based warfare. And what's really getting me is the skill, the character skills, and and the way to play the different characters. It'll be really awesome. And yeah, I know I could just play Team Fortress 2 forever, but you know, there's stuff they can do in that game that they just can't do in Team Fortress 2, and I'm okay with that. I don't mind if I'm being ripped off. It's not that much of a big deal to me. Okay, so anyway, let's play some Scout. Oh, it's been ages. What have I got equipped? Whoa, okay, hang on. I can't see my face. I'm supposed to be able to see my face in the top right corner, but it's got a problem, so I can't see it. So let's see, I've got the shortstop, bonk, atomic punch. Okay, let's change this. Let's get the guillotine. I'll stick with the shortstop for the moment. What's this? Pretty pistol. Gain up to 2 health when you hit. Oh, that's interesting. Is that new? No, let's no, we'll try it. And I'll stick with this for the moment. So let's go. Let's see how I do. Maybe I'll do terrible. We shall see. Oh wow, the sensitivity definitely needs to be put up.
Remember me? Yeah, you do.
Maybe need to turn up the sensitivity a bit. I should have hit him a couple more times with the shortstop. Oh, so many of these crates, no one really wants them, so I just kind of keep them. Should probably trash them or something, but you never know. So I'm not that much fun to talk to during these games. I'm not a good commentator, which is probably why I'm not a professional YouTuber, but I'll figure it out some way, somehow, maybe? I'm not sure. How do most people... I don't know how they do it now. Jesus. Oh well. I guess this is why people don't watch people that are good at games, because people that are good at games might actually be boring to talk to while playing games. Maybe if I had some friends to talk to, like a lot of them do, then it wouldn't be so hard, but oh well. Okay, that kind of seems suspicious, almost like it was a spy, but spies don't often go with the same team that they're on, so probably not the case. I'm not doing so well. I need to do better. Let's get Mad Milk, and I'll take I'll keep this for the moment. Wow, a lot of scouts on my team. Wow. Okay. Oh, come on. Should probably have moved around more. Oh well.
Mission ends in 30 seconds.
Gotta take the hill back. I've been sniped. There's a sniper over there. Holy crap, man, what have they got there? Some type of nest. And this is new that you can see their health. Or maybe that's a server thing? I don't know. Anyway, I think we've lost this match, so... Oh, gosh. Whoa, whoa, we're taking the point. Oh, we were. We are? Holy crap, we haven't lost this match. Never give in. Never surrender. It's not over till the last card is played. Okay, now I've got to defend this point. That is... Looks like a spy, but it wasn't. They're probably going to take the point back if we're not careful.
The control point is being contested.
This guy is named Microsoft PowerPoint, which is kind of funny. Maybe I should get the this thing on. Alright, let's go. We can maybe turn this thing around. Oh gosh. Whoa, I did it. But I just didn't manage to get the health pack. Oh, it's been so long. I'm a bit of a noob now. I'm gonna have to spend a bit of time getting my skills back. Here. At least he can get his health back when he's at 2 health. Oh. I don't even need these headphones. I can't hear anything through them. I haven't got them plugged in. They're only there so I can talk directly through the microphone. And I could be using the webcam microphone, but it doesn't pick up as easily, so that's why I'm using this one. Not the best, but... Whoa, whoa, whoa. Oh, you do pick up some health from this pistol, which is kind of cool. I'd probably be dead actually if I wasn't using it, so that's really useful, but Jesus, man. Let's go. Let's kill him.
Ends in 30 seconds.
Yeah, got him. All the way.
Mission ends in 10 seconds. 5, 4, 3,
Getting better.
2,
We actually won this. That's awesome, man.
the control point is being contested.
I should never have given up. It's so unlike me. Yet I did it for a second, but then I was proven wrong, or right, or whatever. Don't give in. Alright, one more, maybe 1 or 2 more games, and then we'll I'll probably have to call it quits, because it'll probably be 12 o'clock by then, and I've got an interview for a scholarship tomorrow. As I said, it's not all fun and games, even though school's finished.
Doc, come on, man.
So yeah, that's okay with me.
3, 2, 1. Control point enabled. Move. Alert. The control point is being contested.
Let's get that scout. Oh yeah, got some damage in. Going back for another round. Let's get that soldier, flank him. Okay, we're gonna have to... Ooh man, lucky. Let's get this health kit. Ah, shit. That demo stole my health kit. And I think that guy was a spy that I didn't kill, but that's okay. And I happened to just be lucky enough to get my name in the capturing the point because I was standing over it at the time. Even though I really was off elsewhere, but that's okay. Oh yeah, I'm definitely doing a little bit better than I was at the very beginning. That's not a spy. Good to know. If he was, I would have obliterated him. Wow. That's a spy. Red guy says this team is shit. I don't know about that, man. You almost won last time. It's just that we had a clutch over time and It's like I never hit anything with that. Wait, that is spy? No, it's not. Is that a spy?
Get on the freaking point, dumbass!
Maybe. That, not a spy. That was a sniper. Dealt with him easy though. That's not a spy. That's the one thing I've got to maybe if I gosh, I definitely need a more comfortable playing area. This is like gonna give me a big look at this. Look at that. What is that? Jesus. It's from the edge of the table. I need a smoother I need a smoother arm table transition thing. Other than that, wow. Let's follow this soldier. He is using a rocket jumper. He was not going to hurt me at all. Now it's tickling me. Oh gosh. The wire, I mean, on the thing. Oh, never mind. I definitely need to. It's definitely not set up to play video games. That's for sure. Ah, there we are. Oh, he's done for now.
Mission ends in 10 seconds. 5, 4, 3.
Ah, there's the soldier. There we go. Just need to aim a little better. Ah, look, a scout. How can I miss every one of those shots? Oh well. And one more game after we change this level. Excuse me. Harvest. I've been drinking Coke at the time I was drinking it, because I'm pretty sure I started recording this video about 11. Oh well. This guy. Obliterated. I took a rocket to the face, but he was still bam, bam, bam. Alrighty then.
Let's get him!
Let's figure this out. Alright, let's destroy him. Ready? Set. Shit, man. I should really conserve my shots a little more instead of just let them all out, even if though I can.
Control point enabled. Alright, let's figure this out. Ow, ow, I'm in a wall. Okay, that's not good. Okay, come on, come on, come on, come on, come on, come on. Here goes, here goes. Ah, spy. Die, spy. Get a piece of that. Ah, getting some health. Oh, shit. Soldier. Above me. Spy, 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 spy. Oh, I'm such a good commentator. Spy got blown up. Oh no. What are we going to do? I'm going to run back in. I'm going to try and take the point. But first I need to make sure that no one else is... Okay, that demo didn't get hit by any of my shots. Good to know. Trick the demo. Other scout killed me with a fish. She's apparently really good, efficient. I am slowly accidentally hurting myself with these cuts on this very uncomfortable playing stage, but there's nothing really I can do about it. That sniper almost got me.
But it was the soldier who took the final blow. This is not good. May need to switch classes. Of course, it was a spy. Right, I'm gonna have to get out of here somehow. I'm gonna need some bonk. Probably take the regular bat back, or a fish. And I'll just shoot the sniper in the face. Fuck! I'm so bad at this game. This is why I need to get a new game like Overwatch probably, because it looks like I could maybe be better at that. I'm not sure though. Everything kind of looks easy when you're watching. At least I probably won't get spawn camped like this. I haven't seen any spawn camping at least in that game. Well, obviously I guess it's possible, but never mind. I guess they don't really have a King of the Hill mode though. Spawn camping definitely happens a lot less often in control points or payload, which are the only game modes available in Overwatch, so yeah. Touche. There we go, let's go for this.
Mission ends in 30 seconds.
I'm gonna go around the back and get this turret. Scout here, I'm gonna go for him if I can.
The control point
He hit me with a fish though. Crap man, he almost got me. I'm gonna go get some health. That's a spy. Ah, luckily he stood still for me. And I've also managed to happen to get all 4 shots on this guy. Oh man, and I used my bonk to avoid the damage from that explosion. And I've destroyed that scout, and I'm gonna take this demo man down. Took it down, yeah, oh yeah, like a one-man stomping machine. That was pretty good. You came close to your record for buildings, destroyed a scout that round, 2. Wow, I must be really bad at this game. Or maybe it's a lot more fast-paced and a lot more dying than in Overwatch, because in Overwatch I saw sometimes people get like 13 kills before they die, and it's like, wow, that's almost never happens to me in TF2. Then again, I'm not a pro, but I don't think a lot of these guys were pros either, so this definitely seems like a game that makes you feel a lot more powerful than Team Fortress 2 does. Like, you stay alive for a lot longer, but you also get a lot more kills. I'm not sure how that's even possible. Surely, if you're getting more kills and you're a noob, then other noobs that you're killing, which in turn reflects onto you, are going to be dying more often, right? So I'm not sure how that all works out, but oh well. We got that guy. Ah, almost got him. But the team took him down. We've control the point at the moment, right? Hopefully. But they might be taking it back. Oh gosh, they might win. Ah, far out. One more game. One more game. Okay. Let's try this again. I'm on Team Blue, and we might... Part of the reason we're losing might have to do with the fact that we have 3 spies on our team. I'm just saying. But, you know, we shall see.
I'm a freaking blur here.
Let's destroy this engineer.
Control point.
Oh, come on. At least I got him, but his turret got me. Should have destroyed it. Oh well.
People have really funny names these days. Very Australian names too, some of them. Like ABC News. Seriously? Now. Whoa. Whoa. Another sniper got me. Far out. ABC News is now a sniper. Alright, let's try and cap that point. Alright, I've capped the point, that's what matters. Let's get out of there.
Alert. The control point is being contested.
Let's get these engineer. Oh gosh. Killed by some Chinese character. I literally mean like his name was a Chinese character. Or probably another Asian language. Sorry. I'm not sure. Maybe it was actually like that Arabic one. I'm not sure. Sorry. Oh well. Oh gosh, taking a bit of damage.
Can't hit what ain't there.
Let's grab this. Oh gosh. There's a soldier here. Let's destroy that. I got a spy. Hey, hello, who's there? Okay. Just talking to my sister. Nothing. I'm making a video. Gonna go back for health. Probably a good idea to keep going back for health. Because, definitely a small map, and you can afford to do it, so...
Unfreaking touchable.
That did not work out like I wanted it to. I was trying to go back to destroy the sentry, but I couldn't quite do that. We didn't even control the point. Holy crap, man. Anyway, shit. How the heck, man? Must have shot me in the head with that thing. So, that was another thing about Overwatch, is that, like, you know exactly what what heroes, the enemy heroes have. Also, I think the enemy heroes in Overwatch seem to be a lot more distinctive. I mean, they're pretty distinctive in this game. Like, you can tell at a glance who's who, but even more distinctive in that other game. Gosh, I missed. Got sniped by, like, see, like, spies sniping you is like, what the heck, man? Look, I'm gonna have to switch characters. I mean, that's part of the game too. I probably should be switching more characters. Alright. I suck at this game. Why am I playing this? Oh, because sometimes I'm good at it, I guess. But not well. Is that guy like Sam Keck, as in like Sam Kekovich? That's also Australian. Can't get me now. Oh, how did you get me? Holy crap, man. Let me at least try and get some health back. I'm an idiot. Honestly. I've even got a home wrecker. Well, at least I know where to go now to destroy that sentry.
Mission ends in 10 seconds.
Alright, I'm definitely going to bed now.
You failed.
I don't think this is fun anymore. I'm not sure. Maybe I just haven't got the skills anymore. Anyway, I haven't played in a long time, who knows, but that's that's enough from me. It's also 12 o'clock and I gotta go to bed. Good night. My name is James Ryan, and I have been your host. I wonder if how much I've been in the webcam. Who knows? Good night. Bye bye. See ya.